Hello guys, how are you doing? I hope you are doing fine. And we're going to start with today real analysis. I think what we're going to do first is there is a very simple observation. So there will be two statements P and Q. We're going to imply P will imply Q, and then we're going to see what observation we can make through them. All right. So let's just start with it. So the first thing, let me get my pen tablet right. All right. Let's just start with green as a color. Right. Okay. So suppose P and Q are two statements. So P and Q are two statements. What I'm going to do, I'm going to write that P implies, let's say Q. Now when I say P implies Q, what does that mean? That simply means that if P statement is true, then that will imply that Q is also true. So if somehow I'm doing a problem, let's say, and if somehow I got the result that P is true, that means I don't have to individually find the or check the correctness of Q. Because if P implies Q, remember that this is something that is given to us, okay? So we are not assuming anything. It is given to us that P is a statement and P will implies Q. So let me just use an example to so that you can have a better idea. Let's say P means X is a natural number and let's say Q means X is a real number. Okay, so what I'm going to do now that we know that every natural number is a real number, right? That means if I assume P, that means X is a natural number, that will implies that Q, which is X is a real number, is a correct statement, right? So in this case, P will implies Q. Now let us just take a look at some observation. Let me write observations. So what we can conclude out of this? First of all, P is sufficient for Q. So that means that if only we have this idea, or if we somehow can conclude that P is true, that means it is sufficient to have P to imply Q. So let me just give an example. All right, let's say our original statement was this, right? That is a statement where X is a natural number and Q is a statement where X is a real number. So what I'm going to do, I'm just going to assume something that will imply P to be true. So let's say 5 is a natural number. Now, this is comparing this with P. I mean that 5 is a natural number is a correct statement, right? And because it is already given that if P is true, then Q should be true. So this statement should apply or imply that 5 is a real number, right? And see that this statement is true. I don't have to check for its validation. I don't have to check for its correctness anymore because I know that if P statement is true, it is sufficient just to know whether P is right or wrong to have the idea that whether Q will be right or wrong. And if P is true, that will definitely implies that Q itself is also true. Now let us just find the second observation. Second observation is Q is necessary for P. What does it mean? Q is necessary for P. It simply means that if suppose we don't know whether P is true or not, okay, we don't know it. But suppose if we come to realize that Q itself is not true, so the statement Q is not true, that means that the statement P is not gonna be true either. Why? Because very simple logic. If P as a statement was true, that would have implied Q to be true, right? But if Q itself is not true, that means there has to be something wrong with the P, right? So P is not true because if it was true, then it would have implied Q to be a correct statement. So if somehow we realize this, without finding anything about P, suppose we find out that Q itself is not true, that would imply the P is not going to be true either. So let me just take an example. Let's say uh, that let's say 2i. So 2 iota is a complex number, right? Because iota itself is a complex number. Any scalar multiple, or in simple terms, multiple of iota is a, unless and until it's zero, right? So if we are not multiplying with zero, if I am multiplying with any, let's say, real number other than zero, uh, with iota, that resultant is going to be a complex number. So 2 iota is a real number. So comparing this with my Q statement, I know this is not real number. So what I'm going to do, this is a wrong statement, right? So if 2 iota is not a real number, that means Q statement is false. That means the P statement is also going to be false. So 2 iota is a natural number. This is our P statement, right? But because we know that Q is necessary for P, so first of all, Q needs to be true in order for P to be true. Because Q itself is not true, that means P is not going to be true either, right? Now, if you look carefully, just using the above example, what we can deduce that not Q implies not P. See, when I write this down, the 2i is a real number, right? And this was a wrong statement. So it automatically implied, right, that P is also going to be a wrong statement. So like if you're talking about statements, there are only two possibilities. Either they're going to be true, either they're going to be false. So if we have just proven, then they can't be true. What does that mean? There has to be false, right? So suppose there is a P statement. If I take its negation, well, let's say I say P as a statement, X is a natural number. So what will be the negation of P? That X is not a natural number, right? So if I use not Q and not P, then this statement 2i is a real number is a not Q statement. And if I consider not Q statement 2i is a real number, then it is true, right? That just notice that I have changed the statement consideration from Q to not Q. So let me just define. Okay. So what I meant when I say that not Q. So let's say we know Q is a statement where X is a real number. So not Q will be a statement will become what? Negation of Q, which will imply X is not a real number, right? Suppose X is not a real number. What does that mean? That implies that X is not a natural number either. If X itself is not a real number, that means X is not a natural number either, right? And what this statement is not Q, not P, right? So if I have this statement X is not a real number, and suppose this is true, then what does this imply? That X is not a natural number either. That means in terms of not Q and not P, not Q will imply not P, right? So let's just move to another observation. Not P may, okay, not P may not imply not Q. Let me just think. So when we are saying not P, that means X is not a natural number, right? And I'm saying that it may not be a real number. I think not Q has to be there. So let me just write not Q may or may not imply not P. So let's say not Q. So X is not a real number. Then would definitely imply, okay, that can't be true. not P may or may not imply Q. I think I should write it like this. Let me just select all of this. I'm gonna get rid of this. Okay. Let me write it like this. That not P may or may not imply Q. So what do I mean by that? So this statement not P is gonna be what? X is not a natural number, right? But suppose X is not a natural number. Does it mean that X can't be a real number either? It is a wrong statement, right? I'm gonna tell you why. So, okay. So let's say, for example, 1.5. So 1.5 is not a natural number, right? So not P statement is correct. So 1.5 is a real number, right? And this statement is also correct. That means not P is implying this statement Q. Now I'm going to take a look at the one of the another case where not P will imply not Q. So let's just say 3 iota is not a natural number, right? So what does that mean? It simply means that this statement is right. Now let me just write it down. 3 iota is not a real number either. So 3 iota is not a real number, so this statement is also true. That means not P is implying not Q. So we have just learned that not P can imply Q and not P can imply not Q. So it is not fixed. So we have to check. It depends. On under certain condition it will imply Q. Under certain condition it will not imply Q. So what we will simply write that not P may or may not imply Q. I think there is one more. I'm missing. Like I have forgot what I was supposed to remember, I guess. So let me just think. So we have P sufficient for a Q, Q is necessary for P. Then we have not Q implies not P. Then we have not P may or may not imply Q. Now what I need is not P, not Q. P will implies Q, sure. Q may not implies P. I think that is the only part that remembers, I think, that Q may not implies. I think it was so obvious that, I was just thinking what we can actually conclude more out of it. It is just like the basic of it that Q will imply like Q not Q may or not Q will implies not P. So there is nothing. Not Q may or may not implies P. No, this is not a right statement. I think I'm missing something here. Not Q. Let me check what I'm missing, I guess. All right. So I have my notes here. Q may not imply P. We have done Q may not imply P. Yes. All right. So let me just get this out of here. All right. It's no worries. Just gonna selected. Okay, so now we have the fifth observation, which is uh, Q may not imply P. I just think it is very unnecessary. Like we already know that a number can be a real number, but it is a possibility that it won't be a natural number. But then it is easy to understand in this particular case. Maybe it is difficult to understand when the statements are something else. So this is also one of the observation that we can get. A Q may not imply P. What I mean by this, let's just see that root 2 is a real number, right? This is a correct statement, right? But root 2 is a natural number. Is this statement correct? No, right? Because root 2 is its value is gonna be something like 1.4. I'm not sure about the other values, so I'm just gonna leave it here. I think it's 1.41 something. And obviously, it's not gonna be natural number because natural number is something we use for counting, and they are like 1, 2, 3, 4, right? Nothing in between them. So this is not a natural number. So even though Q is right, it is not implying P, right? So this is what I mean, that Q may not imply P. It may imply, like for example, you could have simply taken 2 is a real number, and then the Q statement will be true, and then 2 is a natural number is also true. In that case, Q will implies P. So the condition is that it may or may not implies P, right? So it actually depends. I think this was it. So yeah, I think I will see you again.